Hey guys, this is a review of the Dr. Meter MD918 Pinless Moisture Meter. They contacted me and sent me a review sample to take a look at, and I'm going to be comparing it to one of their other pinned moisture meters and talking about the difference between these and how they work with woodworking to help you figure out what your moisture content of your wood is and if you can start a project with it or if you're going to experience buckling after you've made something. And if you want to know more about moisture content in wood and how it affects your projects and how you can dry your wood, Matt Cremona has an awesome video on that. He's a much more experienced woodworker than I am. I'm going to link that probably in a card up here somewhere, and you can take a look at that as well. Alright, so the moisture meter comes with a nice little carrying case here. Unfortunately, is not big enough to fit the manual in. The manual gives you instructions on how to calibrate it. It explains it's got temperature compensation. And it's got a little chart in the back here to look up your densities of wood, which you've got to change, cycle through here. Just about all non-contact moisture meters require you to do that. They work by reflecting radio frequency waves into the material and reading how much reflects back. It's, from what I understand, density based, which is why you have to change the density if you're dealing with a softwood or a hardwood. So you just basically hit the mode button and it comes on and it tells you it's scanning. It'll give you an X if it can't scan, and it'll flash at you if it needs to be calibrated, and to do that you got to pull out the battery and hold this on, and I guess it measures ambient moisture in the air and does its thing. To switch your density modes, you can just hit this little button here. You'll go from densities 0 to 9. And you can see it changes the ambient density. I got my finger back here in the pad. That's why it keeps actually reading things. And then if you want to measure moisture content of the wood, you can just throw this on the board. Got 18%. This board has been in my shop for about probably 3 months. 3 to 6 months probably actually. And it's hovering right around, you can see, 17 to 18%. I am in Alabama and it is humid here. So that's not an unreasonable number. We've also got this pin moisture meter that I was talking about, and this measures resistance between these two pins when you stick them in. See, I'm quite wet or moist. I'm not jamming that into my finger, but I've got a lot more conductivity than this board does. So if I jam this into this board, on the face of it, get 8%, which is much lower than the 17 to 18% we were getting by measuring with the non-contact or with the pinless one. And if we jam it in this way, we also get around 8%. Sometimes grain direction matters for boards. And then obviously if you jam it in the end, probably going to get a little bit less since moisture escapes. Not that way better. Yeah, there we go, 5%. So with one of these, you've got to really cut into the middle of your board to figure out what the content is inside of it, especially if you've got a thick board. With this one, you can just set it on top and it does its thing. So now I'm going to cut this board in half and see if we can get a more accurate reading out of this pinned moisture meter. Alright, got the fresh cut board. This is the fresh cut inside. Wow, splintered. And we'll go ahead and try the moisture meter on that. Jam those teeth in there. Well, it's better than 5%. This time it's 9%. Still not up around 17 though. And these, the MD918 moisture meter, these are pretty much dime a dozen. There's a million different brands that all stamp their brand here, and they're all MD918 on Amazon. As far as this one goes, this is the only one in the orange and black color scheme that I've found, of the Dr. Meter one of the MD918. There are a couple others out there in different color schemes, but they all seem to be going for about $10 more than this one. I think they're the same tool though. And since I don't want to just give this thing a rubber stamp, looks good, I actually devised a test to see if I can actually measure moisture content just at a couple different levels with a known weight change to see if I can calculate how much moisture it actually absorbed and how much this thing actually reads for the moisture content of a board. These two boards have been sitting in my garage for well over a year, and they're both right around 17%. If we move this up and down, we'll get like a 0.5% variance over the surface of it. Same with this one. It might bump up to 18 occasionally, but it's pretty much around 17 and a half. Now, if I take a pinned moisture meter and measure the same board, if I just stab it in the face here, I only get 7 or 8% out of this, and these are jammed in there pretty well. If I do the end grain, it's 7 or 8%, right around there. So I'd like to know which one of these is actually accurate. And to do that, I'm actually going to fill up a bucket and I'll soak these. I've actually already written down the measurements. These are in inches, and this is the weight in grams. So this one is, well, I guess I did a decimal, so it's kilograms actually. 0.116, and this is 0.123. They're slightly different dimensions. That's their weights at 17.5% moisture. And what I'm going to do is I'm going to soak one of these upright so it wicks from bottom to top. Hopefully I can get a gradient in that one for moisture. And then the other one I'm going to weight down so it's stuck in the bottom and see how much I can get it to absorb overnight. Take it out, let the surface dry, and I'll measure this again. And then I'll weigh it and see how much moisture it's actually absorbed. So here's the setup. I've got the 116 gram one sitting upright. It's taped there so the bottom is in so the water can wick up. Hopefully we'll see a moisture gradient across that when we measure it tomorrow. And then the other one I've dunked completely underwater. I've got a heavy polymer tapping block for laminate flooring sitting on it. So it's completely submerged. I'm going to let that go overnight as well and see what kind of moisture content we get out of it. So I soaked this one overnight flat, and then I soaked this one from the bottom, just the bottom in, and let it wick upwards. So I measured these afterwards. This one was 0.123 kilograms beforehand, and now it is 0.139 kilograms wet. If you remember, it was like 17.5% moisture, and this one was 17.5% moisture. So this one's going to be our standard. It has gained 16 grams of water. And now when we measure the density, it's up around 26.5, and it ranges various parts of it. About the highest I see in it is 35. I expect the center to be a little bit less than either end because, moisture is going to wick in from these end grain a little bit faster. So anywhere from, well, this one's not that much. It's kind of weird. One end grain wicked a little bit better than the other, it seems like. So this one's right around 25 at this end, ranging all the way down to about 33.5. That's about where the pad starts to come off. So 25 to 33. And this one still got its 17%, 16.5, 17% up at the top. And as we range downwards, you can see it starts increasing in moisture up to about 35%. And I'm starting to get the pad off the bottom here. So it's probably about 30 to 32. And then I wouldn't really trust the reading, I think, after I get off of the main pad. So we are seeing a gradient like we expected on this one, and I'll run the numbers and see what we should be expecting for the weight gain of the water in this one. And I'll go ahead and let's shoot for an average. So we've got 25 at this end, and then 33 at the other end, 33.5. So let's say probably somewhere around 29, something like that. Should be our average that we're going to expect out of this. So here comes the boring math behind the moisture readings I got from this. When we started off, the one block that I submerged completely weighed 123 grams, and it was 17% moisture according to this meter. So I took the percentages and the weight and figured out it was 21 grams of water and 102 grams of pine. Afterwards, we read a variety of ranges from around 25 to 34-ish, around there. So I took the average in between those, say 29%, and we took the weight afterwards, which is 139 grams. So it had gained 16 grams of water weight. We know the pine didn't change. So I took those new readings, 29% water, and multiplied it by the new weight, and we got 40 grams of water and 99 grams of pine. So we've got a 3 gram difference in our pine content, which we know didn't change, and that's about 3% error for the wood. And then our actual weights change is 16 grams of water. That was our actual weight gain. And our measured was 19 grams of water. So that's 3 grams off, just like the wood. And whoops, while I was editing the video, I realized I made a mistake. I calculated 19% off of the delta, the 3 and 19 or 16. So that's actually wrong. I should be doing percent error off of the starting weight or the ending weight, because we know it's off on one of those. So that comes out to 7.5% error if you use this number, 40 grams, to 14% error if you use the 21 grams, like we used, 3 grams and the 102 for water, or 109. It's pretty much the same as 3% either way for those. So 7.5 to 14% error is a lot better than 19%. And even if you're up at the 14% error, remember we're dealing with really small numbers. My weight scale only had a resolution of grams, so 3 grams on the grand scheme of things is not that big. If you're dealing with a bigger board, it's going to be a lot less percent error if you've got a few grams difference in your actual readings. And since I don't know which of these is actually right, because I don't have a 0% water board that I can test with, we're just going to have to accept that there's a little wiggle room in between either one of these, and our percent error is somewhere in that range. So that comes out to, with this dry weight of the pine, 356 kilograms per cubic meter. Pine ranges from 350 to 500 in density, kilograms per cubic meter, so it makes sense that we're at the lower end of that if we're at 0% moisture for the content that we're reading and we're calculating here. All right, and now that we've got this wet sample that we added water to, you can see the pin moisture meter is now reading the same as the pinless moisture meter, but obviously since its swing went from about 8 to 10% all the way to 35, this one's percent error is crazy different than the actual percent error of this one. This is much less accurate, which I'd expect from a tool that costs less than half as much as the non-contact one. And on the face of the dunked board that we have, not surprisingly, it says 23%, which is, much less than the ends, because that's where it's wicked most of the moisture in, is through the ends. All right, so wrapping up, I think this $45 moisture meter is a great compromise between the this $20 pinned one that I've had for probably 5 years now. This is a big upgrade. For twice the price, you're getting a lot more accuracy, especially at drier states of your wood. This thing's measuring way off at low moisture concentrations. It's good at higher ones, but that's not really when you need the accuracy, because no one's going to want to do a project with wood that's 35% moisture content. When you're getting down in the 10% range, 15 to 10% range is just about as low as you're ever going to get when you're air drying, if you're not kiln drying. So this thing is much more accurate in that range. I do love that it doesn't mar up your work surface. You don't have to cut your board and jam it in the end of the new cut to figure out what your actual moisture content in the center is. The downsides to this one is it doesn't have quite the same, all the feature set that some of the other more expensive ones are that are 6 times the cost of this one. Some of those have different depth settings that you have. This one's just one fixed depth that it scans at. And if you put the shake test to it, you can hear a little bit of rattling. I narrowed that down to it's this center up down button and it's this back panel button. If you hold both of those, it doesn't rattle anymore when you shake it. So it's just little fit and finish things that aren't super up to super high quality, but for the compromise of 1/6 of the price of some of those more expensive ones, I've seen them from $200 up to over $300 for a non-contact or a pinless moisture meter. This one's doing a lot better for price point, and it seems to offer a fairly decent accuracy as well. So I'd say if you're a DIYer or a hobbyist woodworker, this thing will definitely get you by. I think it's an excellent investment. If you're a pro woodworker and you're selling your work and you want to make absolutely sure that it's not going to warp on you once you give it to a customer, yeah, you might want to look into a more expensive professional quality moisture meter. But I think this will get just about everyone other than a pro by as far as measuring your wood content, moisture content before starting a project. Alright, so hopefully this review was helpful. Let me know if you have any questions in the comments section below. Hopefully I gave you enough information to make a decision on this. And I do have buy links in the video description. They are affiliate links, so that means I get a small commission. It's the same cost to you. So once again, thanks for watching and don't forget to subscribe.